Okay, so let's look at this last practice problem here. It says a dart is thrown at a target that is supported by a wooden backstop. It strikes the backstop with an initial velocity of 37 meters per second east. The dart comes to a rest in 0.05 seconds. What is the acceleration of the dart? And then in part B, it's asking us to figure out how deep that dart is actually going to stick into the backstop. So in part A, I notice that I just have velocity and I only have time. So I'm just going to use my regular acceleration equation, which is acceleration equals velocity divided by t. So whenever we can go back to the basics, that's what we're going to try to do here. I'm going to substitute in my velocity, which was 37 meters per second, and I'm going to divide that by my time, which was 0.05 seconds. There was a 0 at the end of this too. When I do that, I end up with a number of 740 meters per second. Now, I think that we can all agree on this number of 740. That's what comes out of our calculator. What we need to talk about, though, is what this 740 means and whether or not it should have a positive sign in front of it or a negative sign. So let's talk about this dart. This is me. I'm standing here, beautiful piece of art. I have my dart and I'm throwing it at the board. Okay, so here's the board right here. I'm assuming if my velocity is positive, that my dart is actually moving in a forward direction. Okay, so we're gonna assume that moving right is forward. This is my positive direction. If my dart didn't hit the board, it would keep going. It would keep moving in the positive direction. But we know that my dart is going to come to a stop, which means that at some point, some force needs to work with my dart to slow it down. Okay? So think of this like if you're playing basketball. At some point, defense is going to slow us down to try to stop us from getting to the basket. It's going to work in opposite of the offense. So at some point, there is some sort of acceleration happening or some sort of force happening in the opposite direction. And we call backwards negative. If forwards is positive, backwards has to be negative. So if I'm looking at this, if I'm looking at my 740 meters per second, I can say that this is positive in the west direction, in the left direction, or, and this is the really important one, I'm going to say that this is actually negative in the right direction, which we also call east. Okay? So that's super important that I'm saying that it's negative in the right direction, because in part B, it's asking me to find displacement. And in order to find displacement, I need to make sure that everything is in the same direction. So for part B, now it wants me to find displacement. And to do that, I need to use my velocity, which was originally moving east, and my acceleration, which is now moving east. And I'm going to take a quick look at my equations here. And I notice that I have displacement, I have velocity, and I have time here, as well as acceleration. And I only have my initial velocity, which is why I'm going to keep this first formula. So if I go back and I work out my formula here, I'm just going to rewrite it. So my displacement is going to equal velocity 1 times my time plus 1/2 my acceleration times time squared. Okay, and again, that's just the second equation on my big five because I have I'm looking for displacement. I have my initial velocity, how fast we were going in the beginning. I have a time interval, and now I have an acceleration that we just found. Okay, so I'm going to use this to calculate my displacement. This is what I want my displacement. I'm just going to plug and chug here. I'm going to put all of my information for V1, time, and acceleration into my equation. So I know my V1 is 37, and it was actually 37 meters per second east. I know my time, which was 0.050. I know my acceleration, which was actually negative 740 meters per second east per second. Sorry, this should be squared here. I just noticed that typo. Per second squared east. You don't have to write that. I haven't been writing those. And then I'm also going to write my time, 0.05 squared. Okay. And again, this negative here is super important. And we have to have a negative because I can't have easts in my equation and wests. That doesn't work. Oh my goodness, this is solid writing here. Okay, that doesn't work. They all have to be in the same direction. So remember from that first displacement lesson that we talked about, we can say something's positive in the east direction or it's negative in the west direction. As long as we're switching that sign, we can go back and forth between east and west or north and south because they're in the same plane. They're on the same field. Okay. So I'm just going to use my calculator to grind these numbers. 37 times 0.050 is 1.85. Negative 740 times 0.50 time or divided by 2 is actually going to give me negative 0.925. So when I put all of this mess into my equation or into my calculator, I end up getting negative 0.925. Don't forget that we're squaring the 0.050, then we're timesing it by negative 740, and then dividing everything by 2. I'm left in this final stage of my equation, and I notice I have a positive and a negative. Recall that any signs that are opposite are just going to be negative. So this is the same thing as saying 1.85 minus 0.925. And when I take that into account and put it into my calculator, I end up getting 0.925, which when we round for significant digits, that's going to equal 0.93 meters. And this is all going to be in the east direction. Now, let's talk about this one more time. It makes sense that this is going to be in the east direction because if I go back up to my stellar drawing up here of me throwing this dart and it's moving forward in that right direction or east and it's sticking into the board, it makes sense that it's going to be sticking in point east because if it was going point west, it wouldn't be into the board. So think about that. So my dart is flying from my hand into the board, which is east. Okay, so it makes sense that it's going to penetrate that board and keep moving forward in that east direction. So that's it. That's my answer. That's my final answer. This is one of those questions where you might have to use something from part A to help you in part B with those big 5 equations. Hopefully this helps. You guys are going to have more practice tomorrow in class. If anything else comes up, please just shoot me an email and I will try to help you out. I hope everybody has an awesome night.